Today we're going to look at how the chain rule can be applied to a simple gearbox. If we have a simple gearbox, we have a handle over here and we turn the gearbox is going to have gears in it. For every one gear or one tooth on here, there's three tooths on this gear. So this is a 3-to-1 ratio. For every one tooth on this gear, there's two tooths. So this is a 2-to-1 ratio. So as we spin this dy and we're going to pull down on this gear is going to end up going in this direction. And since this gear is going in this direction, it's going to pull this gear in this direction. So dx and dy are both going to rotate in the same direction, although du is going to rotate in the opposite direction. So if we use this gearbox, we can take this gearbox and apply it to the chain rule. How would we do that? Well, let's just say that dy is going to be equal to, just pick a number, we'll just say 9 revolutions per second. So you're taking this little handle here and you're spinning it 9 revolutions per second. So what is going to be my dy du? So dy du is going to be equal to my dy, which is 9 revolutions per second, divided by, well, du, this thing is going to be spinning at 9 revolutions per second divided by 3. So this would be 9 revolutions per second, or times 1/3, because that's my gear ratio. And this ends up being, well, if you take out this, you divide out the two 9s, this ends up being 3 revolutions per second. So I know now my dy du is 3 revolutions per second. What is going to be du dx? Well, I know my du is 9 revolutions per second times 1/3, which is my gear ratio, right? Divided by my dx. Well, what is going to be dx? Dx is going to be 9 revolutions per second times 1/3, because that's my du, times the 1/2. So we're going to take this times 1/2 because it's my gear ratio that I'm looking for. This ends up being, when we divide out the 9s, we get 6/1. You get 6/1 times 3. We end up with a 2. 2 revolutions per second. How did I do that? Well, let's look at that. 9 times 1/3 divided by 9 times 1/3 times 1/2. This is going to be, my 9s are going to cancel. My 3rds are going to cancel. This is going to be 1 over 1/2, which is equal to 2. All right. So now I know my dy du, du dx. So I can simply plug those in so they know that dy dx is going to be equal to 3 revolutions per second times 2 revolutions per second. And this ends up being 6 revolutions per second. So I know that the ratio between y and x is going to be 6. Alrighty. This is going to be true in every case. Let's see if that's true. Let's spin this at a different rate. Let's say we have dy as being, 25 revolutions per second. So now we're taking this little handle here and we're spinning it 25 revolutions per second. I might end up putting a 5 there and make that more mathematically true. 25 revolutions per second. So I'm taking this little handle and spinning it 25 revolutions per second. Let's look at my dy. Du. This is going to be 25 revolutions per second divided by 25 revolutions per second times 1/3. Right? We're going to end up with 3 revolutions per second again. And I think you see the pattern. Du dx is going to end up being 25 times 1/3. So this is 25 revolutions per second times 1/3, because this is my du. Dx is going to be 25 revolutions per second times 1/3 times my 1/2 ratio over here. This ends up being 2 revolutions per second. So I know that my dy dx again is going to end up being 6 revolutions per second. No matter how fast or how slow you spin this, the ratio between dy and dx is always going to be 6. So if you spin this at 25, you know that dx is going to be 25 divided by 6, whatever that ends up being. So the dx would be end up, if you want to know the speed of dx, you just take it. It's going to be 6 times less than 25. So this is a nice example of how the chain rule can be used in a simple gearbox so that you can kind of get the concept of how the chain rule works. I know there's a mathematical way of doing this, but this is just putting it in terms of like a physical thing. Thank you, and I hope you subscribe.